This is the London FinTech Podcast, brought to you by your host, Mike Ballerman, bridging the worlds of suits and t-shirts, of finance and technology, bringing you insights, stories, and inspiration from the golden age of opportunity and innovation happening in London right now.
Hi, this is Mike Ballerman, and this is London FinTech Podcast, episode 124, brought to you in association with Smart Pension. And I'm delighted today to be joined by Charlie Barker, CTO of what the FT recently announced is Europe's fastest growing company, my friends Blue Motor Finance. Not only that, but it's a super special episode on tech. What is tech? No, really, what is it? We all see the word so many times, but only a small minority of the population around the world have actual real experience of what tech is, or if you like, in old money, programming, or in Americanization, coding. It's a very, very weird aspect of the tech digital revolution. Very few of us, I imagine, are plumbers. But most of us imagine we have a good idea of what plumbers do. Of course, not in detail and not what makes a great plumber. But we all have a real feel for pipes, leaks, stopcocks, etc. This visibility is a really interesting way into this whole tech problem. With tech, we only ever see the results, something we use. But we never see the insides, under the bonnet, inside the tech factory, as it were. What are they doing? What tools, what approaches, what challenges? As a kid, I used to love Birmingham's Science Museum. Well, back in the day, Birmingham was one of the manufacturing centres in the world, adjacent to the so-called Black Country, where the Industrial Revolution grew. This left it with a great science museum which is full of huge objects. As a small kid, I'd stand next to some giant steam engine, some steam train, and even if you couldn't see the insides, a bit like the world of the plumber, all of the, quotes, tech was clear. Wheels, boilers, racks and pinions were all visible. But the development of human society and technology has reached a very abstract stage. What's the equivalent of 19th century steam engines? Obviously the computer, the PC, the phone, the chip. But if you take your kids to a museum of modern day technology, they at most get to stare through a cabinet at a chip in which nothing whatsoever is visible. Having done some turnaround projects for banks, screwed up IT projects, it's clear to me that most FX folks have no real understanding of what tech actually is. In fact, you can, insanely perhaps, be a qualified project manager and not understand in the slightest what your tech keys are actually really doing. Another show entirely, but to me those folks are just bureaucrats. And generally, of course, I scraped up the mess left behind by such people. The interesting thing to me was that even within IT, as it used to be called, the average understanding of the field was very low. If you have a new system being installed in your bank, the chances are that most of your tech folks are in a sense only feeding parameters into a huge system that expected them. They're not doing the real programming/coding. That's what the companies you buy in the software from have done. Charlie, as well as being CTO of Europe's fastest growing company, was also the chief system architect at Wonga. Wonga may have crashed and burned some time ago, but that was for totally different reasons. Their tech always had a great reputation. Anyway, Charlie has kindly accepted/been stitched up with Mission Impossible here. FinTech is fin and tech. I don't think I could possibly explain fin in one episode. However, Charlie is younger, smarter than I am, and I'm sure will have no problem whatsoever in explaining everything you always wanted to know about tech, but too scared to ask. Plenty to talk about, so let's get on with the show. Hi, Charlie. Thanks for joining me today.
Hi, Mike. Thanks for having me on your show.
So, you surprised me, although I've known you for many years now. We had coffee, I think, about 5 years ago when you were still wandering, in that you said that you were an ultra-marathon runner. Now, I'm not surprised insofar as you look fit, but due to problems attaching the microphone to you, you peeled off your garments, or at least some of them, revealing sort of impressive muscles. And I didn't think sort of ultra-marathon runners were supposed to have impressive muscles, or rather, if you did, you sort of kind of burnt them up over the 1,000 miles.
Yeah, I think I wouldn't hold myself up there as kind of an elite ultra-marathon runner. I turn up at the start and I hope to get to the finish. But I've done a couple of races in Wales, and it's been quite an experience, very interesting process.
Was that Wales or the marathon?
The race itself, I wouldn't really call it a race. It's more of a kind of you turn up and you start and you finish. A lot of camaraderie along the way. And yeah, it's more about finishing, getting to the finishing post than any kind of posting any particular time for myself.
And ultramarathons range from what length to what length?
So anything that's kind of over marathon distance would be considered ultramarathon. The races I've run are at the short end, so about 40 miles.
40 miles a short end?
But there are guys out there doing 100-mile, 200-mile races and in deserts and in the polar ice caps and all sorts of things. So that I'm definitely at the tamer end.
It's all relative, isn't it? Yes, I mean, one of the things about life is that there's this exponential thing. You can be good at running when you're in infant school, and then you get to junior school and senior school and clubs and counties and countries, and it's very exponential. So how much training volume do you have to do to be able to turn up and run 50 miles? I mean, 50 miles to me seems quite a long way to drive, let alone to run it.
I think it's all about toughness.
Ah, that's where I'm going wrong. You put your finger on it.
You have to build toughness into the things that are going to carry you, and that's your legs. So it's less about being incredibly aerobically fit, and it's more about just kind of getting out there, pounding the pavement, and just building toughness so you can endure that length of running. Obviously, the more you train, the better you get, the faster you get. But for me, it was always just about making sure I did enough training so I could get to the end of the race.
Wow, it's impressive. Well, of course, there's an obvious lead-in from having to build in toughness to the life of a CTO in a fast-growing company in which you've worked in a few by now with great success. And as we're talking about last episode with Rosber Batcher, entrepreneurialism in itself is a marathon or ultra-marathon, and the one thing that's required there is resilience. And resilience goes a long way. But before you were big and strong and resilient and robust, you were smaller and weaker, I assume. And so at what stage did you first sort of play with a computer, or as it were, when you got sucked into it?
I think my first computer would have been a BBC Model B, so I think plenty of kids.
Which year is this, roughly, then?
So that would be going back to round about, I guess, 1983, from roughly from memory. So yeah, I was kind of, a 12, 13-year-old kid, and this computer arrived. I think my dad bought it. And we could play games on it.
What games did you play on it?
Oh gosh, there's a question. I know Chucky Egg springs to mind.
Right.
Games were freely available if you knew the right people at school. And then you could program on it as well. It had BASIC built into it, and you could write little programs, and we used to do that at school. We had a class once a week where they taught us how to do that. So that would have been my first taste of what a computer program was, and very simple, print hello and go to 10 sort of thing.
Yes, exactly. Well, we were overlapping then in 1983 because I was also using the BBC Micro, but kind of actually the same purpose, but I was finishing my degree at Cambridge in computer science, and the project I was doing, we'll talk about tech in a bit more in a minute, in terms of software, it's another word for tech in this context as a shorthand. I was porting a Modular 2 compiler from the VAX to the giant IBM mainframe. Anyway, in those days, computers were a bit slower, so I would compile my project, and that would take a sort of half an hour or an hour. So I'd have plenty of time to play on the BBC Micros, which were sort of scattered around, and which were literally the other end from an IBM 370, vast kind of old-fashioned 1960s sci-fi looking air-conditioned rooms, yada, all this kind of stuff. Yes, and play Defender, which was a nightmare, actually, because I found Defender was really, really, really tough, actually.
That was a tricky game.
Right, OK, well, look, we'll catch up with a bit more about sort of CTOs later. And in terms of tech, maybe we just start with, as it were, a little bit of a potted history of software per se, and then get more on to how tech works in the fintech way and being a CTO and how it interfaces with business and all that. My first experience was not much earlier than you. In about 1979, I wrote my Hello World program on a teletype at school, which was connected to a computer in the University of Birmingham by a telephone wire. And a little bit before that, in the 70s, I had a TI-58, which was one of the first programmable calculators, which I programmed it to play drafts. It's a funny thing, I often reflect on the fact that I've done about 2 or 3 things that I think are seriously impressive in my life. And almost all of them nobody else knows about whatsoever. So, and even this one now, people go, oh yes, you programmed this calculator, so what's a big deal? Well, it actually was a big deal to program a calculator to play drafts. Going back to the fact that computers used to run far slower, which was a huge problem in the past. It played drafts perfectly fine, but it would take 3 hours a move. So you needed teenage boy patience to get on with that. But when I was, as I mentioned, doing computer science at Cambridge, I was very lucky to still catch the tail end of the people who had literally invented computers. I mean, broadly speaking, before the Second World War, there were no computers as such. If you read histories of computers, then, of course, you've got to define the word computer or stored program, computer or stored memory. Let's not worry about that detail. But I vividly remember my first lecture on the history of the computer, which Cambridge believed that it invented the first one, and Manchester believes it invented the first one. I think some Americans believe they did. There was different developments going on, but they were all definitely developing something along those lines. And still remember now, the line was that after the Second World War, people had loads of radar parts and other stuff lying around, so they decided to build a computer. So that was the story. And I think, as I mentioned in the podcast before, one of the lecturers at the time had still been around when they had mercury delay lines. So one of the problems with building early computers in a hardware sense was how do you store stuff in the memory. And so one of the ways was to have a 30-foot tube of mercury, literally send a ping in at one end and a ping comes out at the other. And that's how you stored some of the early bits in the early days. So one of the things about computers is that it started with hardware. We're all familiar with hardware these days. If you're driving a car, you've got a gear stick. You move the gear stick to a different position, something different happens. And in the very earliest computers, it was exactly the same thing. So you had a bunch of switches on the front. I mentioned before in the early 80s, having seen CAP, a computer, an experimental computer at Cambridge, I actually did see somebody toggle a bunch of switches on the front panel to actually literally load one byte of information pressing a button. So hardware devices have been around for entire history, but the interesting thing is that at a certain point, people developed this thing called software, which is you could load somehow, let's not worry about how, you could load a bunch of sequential instructions into your bunch of wires and transistors and all that kind of stuff. And as a result, a bit like changing the gear lever in the car, what it came out with varied. And of course, that's the whole start of programming and software. And then just very briefly to run through that, at the beginning, it was literally switches. You switch them up and down because computers operating binary, zeros and one. That then moved into machine code, which was pretty much the same thing, a whole sort of bunches of zeros and ones or expressed in hexadecimal. After that, assemblers came along, which is a bit more like programming my calculator, actually, and they give you tiny little instructions, but still one little tiny instruction at a time. Add 3 to this register, add this register to that register, compare two numbers and do this or do that. But that was still sort of very low level. And then high-level languages started being invented in the late 50s, 60s. Most people may have heard of things like Fortran or BASIC, or COBOL was the big thing for tech in business in those days, the actually ghastly language. And as I mentioned before, I have been told by people still in the city, there are still some programs running on computers in big banks which were written in COBOL way back in the day, and they got compiled, i.e. turned into machine code, and nobody's got the source code for them anymore. One of the things about COBOL, it was designed to be, this is a laugh, it'll make you laugh, read by management, and therefore it was more English looking as opposed to the programming languages. Later in the 60s, we had something like the crazy language Algol 68, the world's strongest typed language ever, which was interesting. I worked with a couple of guys, actually, that maintained an Algol 68 compiler in the early 80s. And so when I were a lad, 80 to 83, and being taught about computing as such, it was very much focused on languages. So as I mentioned in my dissertation, Modular 2, that was a simplified Algo-like language where it was starting very, very early days to address the problem that if every time you wrote a computer program you had to start from scratch, everything was going to take ages, which it did. So there's the idea that you could start recycling code, and Modular 2 was one of the first attempts at that. So you had the programming languages, so literally going from all these switches to something where you could type down and write print hello world, and something which anybody familiar with maths wouldn't take very long to catch on with. Programming languages themselves were setting in the context of operating systems. What's an operating system do? An operating system runs your printer. It attaches to the keyboard. It's all these things that mean you can run a program. You can't just take a program and kind of throw it at the computer. So we had the development of operating systems. Actually, you can take over once I get to the late 80s, but people these days are familiar with them very much in the style that Windows is, which is a very graphical interface, which was nicked from Apple, who nicked it from Zero Park. Real tech people like you probably still do the old-fashioned thing, which is you type in a line of instructions to the operating system. And then in the early days of computing, in terms of networks, which obviously is going to lead into the internet, there weren't really networks as such. So if you were using the IBM mainframe, which could take, I think hundreds of users at Cambridge. I mean, if you were just doing a dissertation in, Anglo-Saxon, Norse and Celtic, you might type it up on the computer. Basically, there's like 1,000 dumb terminals with a wire into the mainframe, and all the information was in there. So to the extent you needed to share it with anybody else, somehow there was a way of sharing information, because it was in one computer, one big humming machine in a huge room. But you mentioned the BBC Micro, very, very ahead of its time, actually, in terms of personal computers. But after a while, people started to wonder how you connect all this stuff together. So in the early days of networks, Cambridge was pushing this thing called a slotted ring, which you can imagine is like a little railway train going around with sort of little wagons in, and you put data in, and they believed that'd be more efficient. But the one which, by and large, got more successful was Ethernet, where if you've got something to say, it's very much like Parliament, you stand up and you yell. If someone else is yelling at the same time, you both shut up, and then you stand up and yell again at a random period, and then that caught on. So basically, that's a sort of very quick run through. So back in the day, in the early 80s, before the word tech was ever invented, it was about high-level languages, so you could write programs. It was about operating systems. It was about early, small area networks, local area networks, and there was an inkling that somehow if you have to be able to reuse code going forwards, it might make things more efficient. But that's literally where it is. So if I hand over to you, Charlie, by the time you're about 21 or 22, which is the early 90s, I saw yesterday was the 30th anniversary of Tim Berners-Lee, the inventor of the internet, putting his proposal to management, who said, this is a bit crazy, but it's interesting. No, naive but interesting, I think he said. So If I now hand over this bit of the story, which is what is software per se, before we go into the sort of the broader businessy stuff and development stuff. So what is internet? I mean, there are things like TCP, IP and all this kind of stuff.
Yeah. Well, fundamentally, at its root, it is how do we connect computers together and get them to talk to each other and send information backwards and forwards between them in a way that they all kind of more or less understand. So it's a set of rules in which the computers agree upon. This is how they're going to communicate. TCP IP is effectively your address. So if you live at number 1 Windsor Gardens, well, your TCP IP number is effectively the equivalent of your address. And if people want to reach your computer, that's the address they need. DNS came along, which is basically just create a human-readable form for that address.
Which is like www.bluemotorfinance.com.
Yeah, sort of look up your postcode type thing. And so with those bits of technology, all of a sudden it became, that was the enabler of, well, if I want to put my server onto the internet, I'm able to do that. I'm able to publish my address. Tim Berners-Lee work around kind of the World Wide Web gave us a kind of framework for how do we create a document on this new internet. And then people started thinking, well, how do we discover what's out there? How do we actually find all these websites, and eventually you end up with something like Google, which is a tool that will just go around and find all the websites and give you a search box where you can say, well, I want to find Mike Ballican's for London FinTech podcast. So you punch it in and up it comes. So that's kind of the journey that's been going on there.
And the internet, as everybody should understand, the internet is kind of this protocol, as you say, for connecting all computers around the world if you want to connect them in. And one of the important things that I probably didn't make out, and it comes more important as the story develops, is that one of the difficulties of tech is that there are layers upon layers upon layers upon layers. You've got the hardware, you've got the machine code, you've got the assembly language, you've got the high-level language, you've got the operating systems. And in the same way, the internet is a bunch of connection protocols, and on that the World Wide Web runs, which is the web pages. But also on that runs something completely different called email.
Yeah, so email I think probably predates the World Wide Web slightly. I think email was the first kind of thing that people started using on DARPANET, and when you had academics communicating from universities across email before anyone was doing anything on the World Wide Web. And again, it's just another protocol, another way to exchange information. And this time it's not effectively like a real-time exchange where you're sat in front of a thing and viewing it. It's you package up a message, you address it to where it needs to go. There are servers that can translate that address into a server. They send it to another server, and then someone logs into their machine, up pops their email, and they read it. And obviously this was... it probably blew people's mind the first time they saw it, because prior to that you had to stick a letter in an envelope, seal it, put in a stamp, send it on its way, and then a few days later it would arrive at its destination, whereas email was almost instantaneous.
Yes, it's interesting looking back what was expected and what wasn't expected. So we've had a renaissance of machine learning and AI and all that kind of stuff, and it's all hot and sexy, and it does some great things. I mean, AlphaZero and all those guys are doing phenomenal things. But that was expected. So AI started in the 60s. That was known about. And actually AI, as we discussed on the podcast in the past, was a huge disappointment in that it did not live up to early expectations and all that kind of stuff. So that was utterly expected well before I started playing with computers. What wasn't really expected, I don't think I met anybody who ever mentioned it ever in the early days, was the convergence of computers and communications. Nobody really expected that.
No, I mean, it's very much part of what makes computers valuable is the ability to exchange information. And, I mean, there's so many parts of the world that are influenced by it, whether it's how you get your music or how you watch your TV nowadays or how you communicate with your friends on your phone. It's everywhere. It's pervasive. You only have to look at kind of how everywhere you go now there's Wi-Fi. You can't get away from Wi-Fi, or you can't. You look at your phone, you've nearly got a signal. You've got to go to maybe the north of Scotland to get away from the 4G signal now.
Or a little bit west on the A25 when I was driving here, Charlie, because the country is still not that well covered.
There's a few dips here and there, but it's still pretty phenomenal how quickly we've become almost always connected to the internet at all times almost.
Yes, and one thing implicit in what you say, talking about these things that have converged to create the world that we have where everyone's got the phone in the pocket and, I don't know, you can arrange car finance or listen to my podcast, or the bizarre sets of things, is the exponential improvement in hardware. If you said to anybody in the late 70s, oh, you'll have a camera and it'll have a chip in, and no, because the chip would be the size of a room.
It's very hard to make anyone understand or give any sort of example that is meaningful to people of kind of where this stuff started and where it's ended up in terms of just processing power and how much more processing power is out there and just how accessible it is to everyone. So in a way that I think that's been part of the revolution of tech is just the cost of this stuff has just come down in orders upon orders of magnitude. Made it so much more accessible.
I first saw a CD, for example, I think in 1984, and there's a lead-in of digitising almost anything. So yes, so anyway, so we've got the exponential improvement in hardware, the exponential decrease in the price of hardware. We've got communications, we've got computers, we've got the internet, we've got the email, and we've got search engines, as you say, and people are familiar with these things in the 90s. So if we pick up the story in the sort of late 90s, and Charlie, then just to join into my thing about, let's just start the sort of programming languages, for example. I mean, going back to this point about in banks departments, a lot of them are parameterising, I don't know, sun guard systems or something. A system's coming, you parameterise it. But in a fintech, just to give you just a really simple question, what percentage of the people in the tech department are writing programs, should we say?
Well, use Blue as an example. We've got about six developers full-time working on producing code. We're currently a business of about 200 people, so it's a relatively small percentage of people. But there are people that are actually working alongside those guys, so probably another 10 people that are working alongside them. And they're doing things like trying to understand what we need to build, trying to kind of help build requirements documents to make the developers' lives easier. We've got people that are looking after the infrastructure where we actually deploy the code once it's been built. So there's kind of, design, product development, and kind of infrastructure that needs to be taken care of so you can actually allow the developers to use the code that they're writing.
So in terms of this black box called the tech department or the IT department in your business, be it small or large, what I mentioned before about factory tour, if you walk into that factory, then you see these various departments within it.
Yeah. From
the outside, people think, oh yeah, Charlie is running the tech department. But within the tech department, there are very different roles.
Yeah, definitely. A lot of the work that you have to do is kind of almost deciding how you're going to go about the process of writing software. Every context is different. Financial services is different from various other types of business. Most of what you're doing is you're thinking about risk and how you can mitigate risk. So it's either risk of building the wrong thing, risk of when we make a change to a system, what are the impacts going to be, risk of, not delivering stuff in time, various types of things, and most of your strategizing is like, well, how can we mitigate these risks that are going to be present?
Yes, so that aspect then is the software development and the business stuff, and we'll come on to that. Starting the guided tour inside your factory with these half a dozen in your case. Now, I should say to contextualise this, by the way, that, as I've always mentioned, you run one of the most efficient tech departments in terms of percentage of the overall company out there. Tech percentages may rise massively, I don't know. I mean, I probably have seen some fintechs where they're 50%.
Yeah.
Techies.
Definitely, yeah.
Or even more. I mean, Blue Motor Finance, as I've mentioned many times, I think, is a firm which is spread around the country, has got salesmen and people wearing out shoe leathers and that. So it's a big business. But an opposite, the Revolut, they're all sitting in there, and they're just all, not all coding, but they had one marketing person when I was around there a few years ago.
Yeah, I mean, you get businesses that have just, the Starlings and the Monzos where they've started online. Everything they do is online.
It's all virtual.
Yeah, it's all on as far as the customer is concerned, it all happens on their mobile phone. And Blue is B2B in many ways. So we have relationships with lots of dealerships up and down the country. So we have personal relationships with people. And the tech is designed to support those relationships and grow that. So it's more of a hybrid model.
I didn't want people to come away with the idea, well, if they hire you, maybe they can do it, but the average fintech has got 3% of people doing code.
No.
I suspect that's a low water.
I think we're lean.
You are very lean, yes. So, finishing off in the developers then, with the software, having started the software story and all that kind of stuff, what are your developers using and doing now? Are they still doing things in BASIC and COBOL?
No, BASIC and COBOL is not in our toolkit.
You'd never live it down if you were.
Don't get me wrong, I think you can make a perfectly good living as a COBOL programmer these days. I mean, there's a genuine shortage out there, and if you are so inclined and as a young graduate developer that you want to learn COBOL, you'll make a good living out of it. It wouldn't be my first choice of a language. As you rightly point out, languages have developed, they've become a lot more sophisticated. We're a Microsoft shop, if you like, so we work on a Microsoft stack, so we're naturally inclined to use C# basically as our tool for most jobs.
And C# contains what kind of elements that weren't there in the early 80s, should we say?
So C# is in the same way that Java is. It has a runtime, so effectively it executes inside the runtime, and that gives it certain advantages.
So what does that mean in English? For all the people out there like my mum listening who's going to have got confused by executing runtime.
If you were writing in C, you'd compile down to a native executable, and that native executable would have to be compiled for a specific operating system.
So let me just translate that into the language that people might find even simpler, which is that back in the day when I was doing programming in the early 80s, you would write your program. You would have to do this thing called compile your program, which turned it into machine code. Let's keep it simple. Turns it into machine code, ones and zeros that your little chip actually understands. It only understands ones and zeros. So you sit there, and then, as I was saying before, I'd compile my code. I'd go off and play Defender while that was happening. Once the code was compiled, in modern money, I could just double-click on the thing it had compiled into, all the ones and zeros, and then it suddenly run and it would suddenly do whatever it's supposed to do.
Yeah, and that's great.
So that's the old school approach.
But the problem with that approach is the compilation process will look at your machine, it'll understand the processor architecture, it'll understand the operating system, and it'll make choices based on that, such that
it won't run anywhere else. So if you compiled something for the BBC Micro, it wouldn't run on my phone.
Yeah. So the runtime is designed to create a layer, yet another layer, that protects you from all kind of obscures what's going on underneath on the operating system and the hardware, such that you only need to compile that code the once, produce that program if it's a program you tend to distribute, and it will run on multiple servers or multiple desktops or wherever it's designed to run. Anything that needs to be worked out to kind of make it work on a particular architecture or processor or operating system, the runtime takes care of that. And Java works in a very similar way. The Java runtime does the same job.
So the dimension that's cropped in there was that back in the day, things would be architected for a certain computer, as they still are to a certain extent. Apple stuff and Android stuff isn't the same. But where that developed to, and things like Java as an example, Java was supposed to be there to be able to run your coffee machine or your Wi-Fi or anything. And the principle was around a long time ago, going back to these Algol 68 compiler. People sat next to maintain the compiler. There was a so-called front end and back end, and the front end of the compiler compiled it into some abstract thing, and then to put Algol 68 on a new machine, you had to write the back end. I've probably got front and back the wrong way around, but anyway, going from M code or whatever the intermediary format was into something else. So that model has been extended to mean that your developers, they write something in C# or Java. They didn't have to worry, metaphorically speaking, maybe they do, they don't have to worry too much anyway about whether it's running on Apple or Android.
No, and they don't have to compile multiple versions if they need to distribute it across different architectures, basically. The other main advantage I can see to having the JVM, which is the Java Virtual Machine, or the runtime, is certainly the way Microsoft have architected is C# actually compiles into something called IL, which just stands for Intermediate Language. An intermediate language is, I don't know, effectively a bit more like machine code, but for the virtual machine. What that's allowed Microsoft to do is build a whole bunch of languages like F#, and they even support VB in the form of VB.NET, and other people have come in and been able to build like Iron Python, and they all compile down to IL under the hood. But that's not a very that's not a human readable form, but that's a form that the runtime understands. So what that's allowed Microsoft to do is kind of develop lots of different languages for different purposes, but still leverage that runtime. So I think it's been quite successful in that regard.
Right. So the average hot developer in fintech would use how many languages in a given year? 1, 5, 10-ish?
It depends on your environment you're working in. You qualified that. You said fintech. Probably at least 2 or 3, because you can't do much without JavaScript these days. If you're doing anything that's kind of web-based, JavaScript creeps in somehow. Some sort of back office type, general GPL, general purpose language, C#, Java, potentially Python or something like that, you're going to know that. And then it really just depends what your company's doing. If you're doing interesting things in the machine learning space, then Python's quite hot at the moment for a lot of the implementation of machine learning. But there are all sorts of interesting languages. Haskell seems to be gaining some popularity at the moment. A former colleague of mine is running a team of 40 Haskell engineers in London at the moment. I was surprised he could even find 40 Haskell engineers. But he did say he trained quite a few of them himself. So I don't think language choice, unless you choose something really obscure, is going to hold you back. It's more about finding good solid engineers to help you build the code.
Right. And for people with no experience of programming languages, learning multiple computer languages is not like trying to speak English, Russian and Chinese, because they're all more recognisable.
No.
Although having said that, going back to the environments, although the aim is always to abstract from environments, it's never quite that simple. So my daughter had to do a Java project over Christmas or something like that. Something about it being examined in some Viva, some live thing or something, or an exam, you got 1 hour to do some code or something like that. And suddenly, quote, suddenly, this is what happens in IT. This is one of the realities we will get to, which is that it all sounds good from the outside, but actually it's dance like harder and more annoying than people might ever imagine. Suddenly, none of it worked, having worked for weeks. And what happened? She'd moved it from one machine to another. It was Java 10, not Java 8, or it was Java 8, not Java 10. And the protocols defined in the manual should use all of them, so it should have worked. But it's this kind of little wrinkle, which is a bit like being a plumber. You and I know about plumbing, but we don't really know about plumbing. There'll be some wrinkles in some type of screw that we don't know about because we haven't got the experience.
Yeah, like you say, after a few years of development, you just expect these issues. They're going to happen, they're going to come along, and the weird and the wonderful. I actually think we're trending towards it's getting better over time. If I think back to sort of 10, 15 years ago and the sort of problems and horrors we had to deal with from day to day, and then I look now, I think things are better. Whoever it is, Microsoft or the people that are developing the languages, they're doing a better job. The operating systems are more stable. We don't have to worry about scalability so much because we've just got so much processors available. So I think it is getting easier, but again, the challenges are getting bigger. Like the things people are trying to accomplish with software are getting, more phenomenal. Self-driving cars, there's a challenge, if you want to, from a software point of view.
Yes. Okay, so I've got that, and hopefully the listeners have got that. Now, then the other thing that has happened, going back to my early 80s experience, is that people try and reuse stuff far more than they ever did in the past. So you don't necessarily, even in my day, if you wanted to work out the square root of a number, you put square root brackets number. You wouldn't sit and write down a function to do the square root. So how has this reusability stuff been addressed over the last couple of decades? I mean, libraries was a word a long time ago. You have a library of stuff and it would do square roots or other things. And then that also interacts with the communications thing. So how do you leverage the resources of the world to write your little program rather than writing a whole routine to print, a whole routine to square root, and all the other things that that's extended to?
I think it's fair to say now you get a lot out of the box. So if you pick a language like C# or a language like Java, they will come with a whole set of base class libraries that, the chaps at Microsoft have worked out how to, do square roots. They've worked out how to do net present values. These guys, there's math libraries that ship straight out the box. So a lot of the simple stuff, the day-to-day stuff that you need to do as part of writing software, you're going to be able to just lean on those base class libraries. In the world of C#, there's strap library, and for everything else, there's NuGet.
So there's new what?
So NuGet is certainly not the first of its kind, but it's basically what's called a package manager. And it's a way that I can say, I've written this little function, or I've written this small library of stuff that does something really useful, and I think, this looks really useful. I'd quite like to use that again in the future. And you know what? I think maybe the whole world might benefit from this. I publish my little NuGet package. Up it goes to nuget.org. And, hopefully I give it a meaningful name so that the next developer that comes along can search for it, find it, include it in his program, and off he goes. There are a few potential issues with that. You've got to kind of be careful that nothing nefarious is getting published. So, the guys that run NuGet have to check these packages out and make sure they're not full of Russian hacker code or something that's going to take over your machine.
Do they get rated? So I know you wouldn't go to something like for the square root, but do people give this a 5-star rating and a 1-star rating?
You can see how often something's been downloaded, which kind of gives you a clue as to how popular something is. I'd say C# was a little bit late to the party. NuGet's not been around that long as package manager tools. I think other ecosystems have had this at the heart of what they've done for a long time. Node is kind of, just like NuGet on steroids in terms of the Node package manager, and maybe they've almost gone a bit too far because there seem to be packages or 10 packages for everything, and so trying to find out which one is a decent package is hard work. But that is a very easy way of reusing code, and the library is huge. I mean, if you go on NuGet, there's hundreds of thousands of different packages out there.
So then you've got the problem which we were talking about in the previous episode, and the information age. The good news is there's loads of information around. The bad news is there's loads of information around. So you need to filter, you need to understand. And going back to being a craftsman, plumbers and all such historic trades, people building steam engines, would have a limited number of tools. The benefit these days is there are an infinite number of tools out there. The problem is that there's an infinite number of tools out there because, again, you need to be an experienced software engineer to know which of the billion tools you can use, you bring into your project. And in a sense, I'm almost thinking it sounds more entrepreneurial in that one of the definitions of entrepreneur I like is somebody who identifies and allocates resources.
Yeah, I think you have to tap into the community. So there's some fantastic community resources out there for developers. Stack Overflow is kind of like, it's the Wikipedia for developers, if you like. It's a question and answer type site. You can go on there, you can ask a question. There'll be someone on there that knows the answer to it. And I don't know how we developed code before Stack Overflow. It really is a go-to site for any developer. It doesn't matter what your language is. So you can get hints and tips from the community about what would be a suitable package to use for a particular problem set. So you can kind of leverage that. But you do kind of build up your favourites, as it were, over time that you've used in various projects along the way.
Yes, absolutely. And I think it's one thing that people may not understand about tech is that all these tech departments are actually sort of chatting to each other about how do you do the square root 4 and yardy behind the scenes, and there is this sort of horizontal network. Okay, and APIs are a bit different from libraries?
Yes, APIs generally solve a different problem. I mean, there's a vast array of them out there now. Generally, it's data you're after, or you want to verify some piece of data, or you want to generate something, a document or some sort of file that you need as part of your process. There's less structure around APIs.
What does an API allow you to do technically? Is it like a square root function? Or I write in my code YouTube, and then suddenly in that part of my web page YouTube appears?
You could build an API to do anything, but typically they're useful where I have some information or data that I want to send off, and maybe I'm asking a question, so I want to know all about Mike's credit profile. So I send Mike's name and address off to a credit bureau, and they give me his credit profile. So it could be I need to gather data, I need to verify data, I need to transform some piece of data from one file type to another. But they're more like a service as opposed to a little widget that you drop into your code. You're making a call over the network to somebody else's system and saying, hey, can you do this for me, or can I have this information?
So within the program that you're writing, the APIs, as you say, is a way to communicate with another computer over there and ask it stuff and it sends it back. The library is a bunch of stuff you can effectively just cut and paste and stick in.
API stands for Application Programmer Interface, so it's not, you could use it to talk about internal code, and developers do, but I think if you're just kind of talking to the world at large, an API is generally accepted as something where you're calling over the network to it and asking a question or sending data.
Okay, and then I don't think we need to touch too much on cloud, which is obviously the other new things. I think people are familiar with that because we all sort of use it one way or another, Google Drive or Dropbox or something like that, but the cloud is just a remote storage of your information.
Yeah, it's outsourcing your data center. You don't have your own, you basically rent one from Amazon or Microsoft or whoever.
So in a sense, we can call that sort of hardware for the moment. Good. Okay, well, I hope that people have got something out of that, if only that these things develop over the time and it gets more complex over time. Just before we move on to that, actually maybe this leads in quite nicely with the challenges, actually. So let's just start with the challenges of doing all this stuff. I mean, you make it sound easy and you're professional, and therefore it all ends up working. But one of the things, having been inside sort of IT, is that it's actually much harder than people outside can imagine. People outside get frustrated when things are, quote, late, but all too many management teams I've seen in banks don't really understand. They don't have any empathy. They haven't run the ultramarathon. They don't actually know what it's like or why things don't work. Now, one of the perceptions that I've got is that, certainly just from doing my website stuff, there's whole layers of sort of, it's a bit like London, it grew higgledy-piggledy in organic fashion, layers of stuff. So if I want to change something simple, I'll give you an example. I had a hell of a problem. I haven't actually slightly given up. The last 10 years, in the sponsors' logos, such as yours, I put them in the centre of a web page. There's no way of doing that. So the one logo or two logos or three, depending on how many sponsors I had, there's no way of doing it. So then I get involved, and there's these things called PHP and CSS and HTML and then WordPress. There's just these piles and layers and just a mess of technologies. So that's a prime example of where doing something simple. You think it's really simple, just centering something on the web page. Well, actually, it proved not impossible. Not only that, I actually did speak to CTOs on how to do it, and nobody knew how to do it. So on the one hand, it's getting more powerful and more effective. On the other hand, at worst, it can be a higgledy-piggledy mess. Once you're sitting not as your guys are, programming on top of virtual machines, but actually once you're a user like me trying to just sort out a web page, there's so many layers of rubbish below you.
It's definitely more complicated now than it used to be. If you go back to when people were first building web pages, just pure old HTML, everything was so much more simple because it hadn't yet developed. CSS didn't even exist in the early days. So a way to kind of style your web page, it didn't happen. I think we've been through 3 or 4 iterations now, and every time the language has been revised, it does more, it's got more capability, so inherently more complexity comes in. So when you're if you're just doing something simple, the barriers to entry are a little bit higher or significantly higher sometimes because the industry's moved on and it doesn't care, unfortunately, about poor old Mike and his website and the fact that he needs to send it, because the industry's focused on, we need to build huge systems and we need to, have all these new capabilities that we didn't have previously because we want to produce amazing websites and web applications that wow people.
And I suspect that for most people that doesn't bother them, because it's only because I know a little bit about these things that I sort of, tear out the stuff and look inside and try and sort of fix a line of PHP or CSS or whatever to move the darn logo. I would have thought that for most prosumers, or whatever the word is, they would just these days use one of the many, many packages for making your website. They wouldn't bother getting into the
Yeah,
details.
there's a ton of companies out there whose business is to make it easy for people to create their own website, and they'll give them templates and they'll make it really easy, and they'll abstract away all the horror that is HTML and CSS and all that kind of stuff. So
exactly, and if you want to flow down those channels, it's perfectly fine and it's very simple. But that's an example, going back to the layers of protocol, that all these layers are still in there. It's hidden from you because then WordPress, Bridget uses WordPress, she doesn't ever do anything like I do with it, and she's got a website, and that's fine. So then you're just using an application.
it feels a bit like using a word processor, doesn't it? It's no different to using Word almost in some regards.
Yes, exactly. Okay, so that's just one example of challenges with this stuff, and the answer is that sensible people, and I'm not sensible in this context, just go with the flow and stick the logo on the side or whatever. And obviously this could be a whole podcast in itself, Charlie. What are the challenges of developing stuff in fintech? What's the reality? I mean, what's harder than it might be? And we'll put to one side for the moment, because I think and people understand this, the fact that the user didn't say what he really wanted and all that kind of jazz. But let's say you've got a good spec and you're asked to deliver this app in a month's time or a year's time or whatever. What are the real challenges?
It's definitely trade-offs. So I'd say all engineering is constrained in some way. So you won't necessarily have the time that you want to do it. So you've got to make compromises there. You've got to make trade-offs and say, well, realistically, we've got a month or we've got 2 months or 3 months or whatever we've got this much time to do this. So that helps you make choices in a way, because if you had an infinite amount of time, well, you'd never need to make a choice. So you're saying, right, okay, once you've got that frame of reference, kind of rough idea of how long we've got to do it, then you've obviously got to look at resource. So who can we bring to bear on this? And then I'd say it's just saying it's managing expectations really in a way. In a business context, you have people intend to get a bit carried away when it comes to what they want software to do. And it's more about managing their expectations and saying, look, well, does it really need to do X, Y, Z? Could we just start with X and see if Y and Z are needed to be added once we get to the kind of the base software?
And a good example of that from the last episode was Burr saying one of the biggest mistakes he's made was for his information aggregator filter content system, that they decided to have it possible to log in via LinkedIn, log in via Facebook, log in via all these things. They spent ages doing it, and then before you know it, LinkedIn's changed its thing. So he said it's such a waste of time. Yeah. Did you need to do that? No.
I think getting your house in order is quite important. So
is that a Jordan Peterson bedroom point?
Clean up your room. I think you need to look at the writing code is great. You can sit there all day and write a lot of code. That doesn't actually change anything in the world. That code has to be deployed and made accessible to whoever needs to use it. And in some ways, version 1's the easiest, because you've got nothing to break and there's no expectations. But once you've got version 1 out the door, you then need to maintain, you've then got an audience for your software that you're using it, and you've got to manage their expectations. And the quickest way to kind of lose that relationship is to not meet those expectations. So if you're building software for a team, they turn up every morning to work, and they turn on their computer, they expect the software to be working and help them do what they do. And if it doesn't work and they just get an error on the screen, you're not going to meet their expectations. So I would advocate for building automated testing into your process so that you catch errors before they get to the team. It's never going to be perfect, but it doesn't have to be. It's just got to be like catch all the stupid errors that developers have made mistakes and they push code. And so try and get automated testing in there. Try and make sure that it runs every time you deploy new code so that it catches the errors before you promote those changes to your production environment. It will give you increased confidence. It'll actually help you move faster. There's a bit of upfront work to be done there, but once you've got confidence in your tests, you'll be able to move faster because you'll have more confidence that when you've made a change, you see your test pass, that you're ready to deploy that into live. Try to make the changes you build into the system post version 1 small and incremental. That really mitigates the risk of building the wrong thing. So you've only put a small amount of effort into it. It gets to the user goes, well, that is just not what I asked for. And, just a miscommunication has occurred or something like that.
Absolutely. I remember the opposite, and I've mentioned it before, at Climeworks in the 90s when IT was very, very poor. It was the old COBOL people and sort of dumb managers that didn't even understand the COBOL. There was a system called Bank-Wide, which was going to do everything, and it's going to be released 3 years' time. Yeah. Funnily enough, what you might imagine happened.
Yeah. Avoid monoliths, so avoid huge systems that have masses of responsibility for across several teams. We try to focus in on a particular team's needs if we're building a system to help them with their workflow or whatever it is, and we try to isolate that system as much as we can from the rest of the world, such that if they come to us and say, Charlie, this system, we need this new feature, or this feature needs to change, if we've got the resource, we can just go and do it and deploy it, and it doesn't only affects them, it doesn't affect the rest of the world. We don't have to go and convene a committee of people across 10 teams and talk to them all and get them to all agree that this change needs to be made. And we don't have all that bureaucracy that goes alongside making the change. So slight downside is you might end up writing similar systems for different teams, but I think the upside is you can move an awful lot faster with your business if you're doing that. So yeah, and just kind of measure the total cost of ownership. Software needs to be maintained, it needs to be kept up to date, it needs to be patched and made secure. So don't start out believing that you will write a piece of software and then you'll get to the point where it's done. It's never done. Whilst it's still useful to the organisation, it has to be maintained. If you fail to maintain it, it can become kind of a liability for your organisation.
A bit like a roof on a house. I was woken up the other night when it was very wet around here by drip, drip, drip on the bed, which is not the thing you want at 3 o'clock in the morning.
No, a roof's pretty important, isn't it?
Yeah, but in this case, how do you know there's a problem with the roof until it's actually gone into the sort of the loft and then wetted something enough, and then at 3 o'clock in the morning starts dripping through your ceiling. So maintenance is an interesting thing because, especially in a world where all these technologies are changing, when one day it's Java 8, then it's Java 9. I'm just thinking about the podcast, simple user application. In the last 5 years, I check it every Thursday morning, or every other Thursday morning when it comes out. I've had twice when the play button didn't work on the website. Now, most people get it via phone, so they'd be fine. But some people come to the website and, holy fuck, what's... so then you're rooting around and, oh, yes, we installed a new version of WordPress or PHP. Was all this kind of stuff is a right pain. So as a rule of thumb, how much resource do tech people have to devote just making sure, even if their own stuff is fine, hasn't been broken because C#74 came out or something?
I would use a rule of thumb of if you've got a developer, so one developer, small development team, I'd say about 20% of his time is going to be used maintaining a new system. So if he stacks up a new system, builds you a new system, I'd allow 20% of his time just to, just the simple stuff. He's not adding any features to it, but he's just, from time to time, he's just going to go and, move it onto the latest version of Java, or he's going to have to update because there's a security patch, or he's going to have to do some work to that system, or there'll be a regulatory change or some sort of change necessitated. And so it's the point that by the time he's built 5 systems for you, he's probably going to be maintaining, that's all he's going to be doing is maintaining those systems.
So one of the things that comes out of this is technology is always changing. An experienced guy like you knows which ones to use. I think I mentioned before, and I think actually I sourced this from you at a Christmas party. We didn't spend all the time talking about boring things like this, which is that one of the amateur errors has always been, for decades and forever actually, using bleeding edge technology. And you've got these sort of overexcitable youngsters who love tech and it's really exciting and this new language is going to solve all problems and all this kind of stuff. And then they start using it and it's fantastic. But then they find that actually half of their work or whatever is actually handling the fact that the new technology hasn't bedded down, isn't stable yet.
Yeah, so when to adopt the new shiny technology is perennial question because it never stops coming. There's always new stuff coming out all the time. I think look at what you're building. If you're building something that's mission critical, then probably finding something a newly minted library that's only been out the door for a few weeks is not necessarily what you want to take a dependency on. Our mantra here is for mission critical stuff, we like to build on top of things that are old, boring and popular. Monzo recently, they've done a lot of work with Kubernetes. Kubernetes is Google's kind of containerization platform. It's a way to effectively deploy systems. That makes up a big part of their infrastructure. And they effectively found a bug in Kubernetes, and that took out their operational systems for a period of time.
For people like me, my card didn't work at Waitrose.
Yeah, from a customer point of view, that was the impact. And they published a really detailed breakdown of everything they did to kind of go through the process of resolving that. And it was really enlightening in terms of things. But fundamentally, and Kubernetes isn't that new, it's been around for a while, but it's all about having people that have got the experience, they've got the scars, they understand the tech really, really well. And, with the best will in the world, the newer the technology is, the less people will understand it, kind of the less robust it is. It just hasn't had enough time in production environments to find all the issues yet.
Exactly. It's like the 747. The 747 has been around so long, going back to my obsession with Air Crash Investigates, that almost every set of conditions that could possibly happen have happened.
Yeah.
And it's amazing how actually that you think you've seen everything, and then there's always something new that crops up. A simple example was on a holiday last autumn. I had to release a podcast. I got my phone all sorted. My phone was in the safe in the hotel. Got something else out the safe. It's quite a high safe, a Thailand hotel, a hardwood floor. Phone falls out of safe onto floor, smashes, doesn't work. At which point, this has never happened before. Now, normally the podcasts release themselves, but I do need to check in social media and so on. At which point I remembered that I'd recently changed my Google password to something incomprehensible. So anyway, that's something that only happened after 4 years of doing podcast. If I do it for 40 years, no doubt there'll be another set of circumstances
that you haven't encountered yet. And so things where you can get caught out are you find that there's a pretty vital feature that just hasn't been built yet, so that can really hurt you. Or if you're in a really fast-growing business and you're scaling like mad, you can actually find that you run out of road. This system's, if you're the biggest company or organisation using that piece of technology, you're the one who's going to find the limits of its performance and where it's got scaling issues or where it needs to be tuned. And that means you're going to have to kind of work with the people that are building it, and that's going to slow you down, and that's going to get in the way of your business and your scaling.
Absolutely. Okay, then I think the final thing, which is the impossible one, which is that this is fine, this is all engineering, but how do you build something that's really cool and sexy rather than just another Waitrose building or Tesco's?
So yeah, I think once you've kind of considered everything we've already talked about,
how hard can it be?
Got that. It's very much about the people. So it's very much about building teams, getting guys that are different specialists to kind of really get together and collaborate and work together. I would say always never lose focus on the poor folks who are going to actually be using this system that you're building it, whether it's your customers or some of your team workers or the user experience those guys are going to get. Always put yourself in their shoes and understand it from them, because good software should be easy to use and maybe even a pleasure to use, and that's where you really get buy-in. Automate away the drudgery wherever you can. So computers are great at doing repetitive tasks or processing or crunching. Humans not so much, and they don't enjoy doing it either. So they'll have get more engagement from your people. And then just take a really lean approach to software development. Just start with the smallest feature set that you think will actually allow a product to function or whatever it is you're trying to build, and then go from there and iterate on that.
And I think one of the things you haven't included there is creativity and imagination. So you told me, I think last year, about a really cool button that you'd installed, which was, maybe we want to tell people about this really cool button.
Yeah, so our COO went to, I think it was BMW Mini, and bought himself a hybrid Mini, which you can plug in and charge up, and you can do sort of 30 miles on it. And he said the process of arranging a charge point to be installed in his house it felt like he was arranging a mortgage, not something as simple as that. So we basically picked up the phone to, I think it was PodPoint, and said we could put a button onto all our dealers can see that we work with, that when they push it up pops a form, they fill out the customer's details, and we send it to you, and you can install a charge point for them. And they're like, right, let's do that. And I think the whole project took 2 weeks. We haven't had an avalanche of inquiries just yet, but I think EVs they're still building EV sales. But it was a relatively small amount of work and it just solved the problem for some of our dealers in a very quick space of time.
Well, I think that's a very nice note to end this long tour d'horizon with, insofar as, from the fintech perspective is a good example. One needs to interface all this with business, as you're explaining, and like all arts, you get to this stage where you need to forget the art, whether it's a martial art or tech, and you need to look at what the world needs. And in that case, you see a problem in the world and you think, I wonder whether we could fix it. Come back to imagination and creativity, and then whether you're a plumber or a CTO, you look in your toolkit and think, I could do that. And in terms of the user take-up and that's sort of slightly by the by, but the idea that you just press a button and it sorts it out, rather than having something which is worse than your quote's mortgage, I think that's really, really cool in itself, actually. And obviously it's one thing that tech companies have really, really got right. I mean, Google's probably one of the best examples. I've never had a salesman come and knock on my door from Google saying, can we sell you Gmail or
No.
search? They're just so cool that kind of quotes it went viral. I mean, I'm simplifying the story, obviously. And so I think that from an art form perspective, at best, you're producing something that adds values to people's lives and makes their lives better. And all the stuff, we started by trying to open up the factory, but to close the factory doors, the real art of a CTO like you is delivering all that stuff. And in a sense, it's almost a compliment to tech departments around the world that the world can get on without people needing to know much about what goes on inside. Having said that, I hope it's very useful for the listeners to get a little bit of understanding of what is inside, because certainly, as was clear from what Charlie was saying, and as I've seen many, many, many times in finance as a whole, it all works best when your tech people understand business somewhat and your business people understand tech somewhat. It doesn't work so well when you've got, shall we say, when you've got sort of English government and parliament going over to the EU and they're really coming at things from different ways and not seeing the other side.
Yeah,
less about that, the better.
Yeah.
So before we wrap up the show, it's been a long show, but it was a special. I wanted to do a tech one for many years, as I mentioned in the last episode. I've finally done it, so if it's longer than normal, At least it's comprehensive, and it's a reference episode people can come back to in the future, recommend to their friends and relatives, so your aunties and uncles, nephews and nieces. Before we wrap up the show, I'd like to thank all the listeners out there. Charlie's been a listener for a long time. You've now had the tables turned on you.
Yeah.
And my brand partner for the podcast, Smart Pension, who are fast, secure and free. Check out their UK workplace pensions at autoenrolment.co.uk. So just to wrap up, I did mention in passing once or twice that you're the fastest growing company in Europe, which is phenomenal. Obviously, the entire secret to that was being a brand partner of the podcast and having Charlie Barker as CTO. And a few people have also played a contributory role. But tell us sort of briefly about the FT1000 and where, I mean, what can you possibly do? I mean, I remember James Hunt talking about winning a Grand Prix a long, long time ago, obviously. And he was interviewed, so what's it like? A bit of anticlimax, actually. Now, I don't think it's anticlimax coming number one in the FT's 1000, but once you're number one, where do you go from there? Once you become the world's ultramarathon champion, where do you go from one?
It's a good question. It's great to be part of an organisation that can kind of put that on its list of accolades. I think businesses go through a growth phase in their early stages, but I think the more exciting thing is what's going to happen in the coming years for Blue. We still are very ambitious. We're still looking to maintain the growth. And myself and the rest of the team here are really not so much kind of looking at that award, although it's great to have it. It's more looking for, well, what's next for us and what can we do? We've grown from 6 people to 200 people in the last 4 years. We'd love to be like the biggest independent motor finance company in the UK. We think we can do that in the next 3 to 5 years, so that's going to be a really exciting challenge. And we're all about making car finance simple for the partners that we work with and for the customer, and just trying to make things fair and transparent. And technology is just a big part of that. We try to use that to our advantage in that marketplace. So it's exciting times ahead, and it'll be interesting to touch base with you in a couple of years' time maybe, and see how that journey is progressing.
Indeed. Well, when I was in here talking to Bob, and Bob was telling us about Ringo playing the first concert with the Beatles that he saw, you were rather smaller.
Yes.
A few years ago, and you have grown exponentially, and I think it's a great tribute to the management team. And Bob's decades of experience definitely help, and as your experience for decades of putting it all into context, and you need this sort of combination of the grey hair and no hair and sort of the young enthusiastic people. What kind of things for the listeners out there who do want car finance do you want to tell them, Charlie? Any breadcrumbs to check out there? Are you recruiting in any areas? You got any big plans for the future?
Yeah, we're always looking for people. As I say, we're growing. This year started strong for us, so we're looking for people if you're interested in being a salesperson.
I'll apply later, yeah.
or any of our operational teams, we're looking for people across the board. So yeah, check out the website, blue.co.uk, and have a look. It's all on there.
Excellent. Well, as I've mentioned many times, and I think the world has improved in a different way in the last few years, as I've said before, which is a few years ago, everybody thought that the thing about getting into the entrepreneurial area or fintech was to go off and do it yourself. At a certain point, it may well be, but actually you're far better off, getting back to daughters, you're far better off if you're a kid coming out of university or school or wherever, actually going somewhere where it's really successful, learning a bunch of stuff, looking around you and working out how it's all how the magic's all done. Anyway, Charlie, thank you for that. It's been a long time in coming this episode. We've certainly got a hell of a lot of content in there. I hope too many people didn't lose the plot along the way, but I think we have connected literally hardware and switches to how you develop cool technology, and I hope that we've given listeners an understanding of the soup to nuts in the tech world and concerns for people like yourself. So I wish you every continuing success in the future. I mean, I think the simple answer to my question about what do you do when you're number one is you keep competing.
Yeah.
You were number 22 overall last year, but you were still top in the FS. So, when you're winning, life is very nice. So keep on winning. It doesn't really matter if you're third next year or second. You could probably live with that. So I wish you every success in the future. Charlie.
Thanks very much, Mike.
Thanks for listening. If you have consulting, advisory/non-exec or media needs in the FS or fintech space, get in touch with me at mike@londonfintechpodcast.com.
We could sit in a bender all day, watching the firelight dance, watching the firelight dance. We could walk in the mountains before dawn, watching a happy moonrise, watching a happy moonrise. come away from the city, but with the tarmac so dead and the people so sad. Come away from the city, but with the faces so grey, with the pain of the everyday. We are wild like the mountains and the trees. Can you see what I mean? Can you see what I mean? When we fade in between the earth and the sky, kiss the city goodbye, wave the city goodbye, wave the city goodbye. The city goodbye. Watch the firelight dance with me. 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 Watch the firelight dance.